Hello everyone, this is Indradeep Kumar, Assistant Professor, IARE, Hyderabad. In this video, we will see the beam deflection due to a point load by the method of complementary energy. Now we will find deflection just because a point load is acting on a beam. For that, by using the complementary energy method. So this is lecture topic, right? Here is this one. So this is a cantilever beam. For that, we will find the deflection by using the energy method. So now just see, this is the dotted one is the original beam, okay, and on the end of that the load P is applied. So once here load is applied, definitely that will bend. So now this is the bent part, okay, after applying the load P. The length of the beam is capital L, right? Now we have to find this deflection, how much this delta V is there. Actually it should be here, but now this is here. So how much this delta V is there, that we have to find. Okay, so now how we will find? Just take a small element anywhere at a distance Z from the end point, where that is, or you can say from the free point. So at a distance Z, take a small element dou Z. Once we will find for the dou Z, we will integrate from 0 to L, we will get the total deflection, right? So this dou Z is required. Now let's see here this one. So this is dou theta for this point where we are taking, right? So this is, so what we know that theta equals to L by R. We know the formula for arc length, right? If we know the arc length and the radius, then we can say this is, we can find the angle theta. So here dou theta is this one, and 1 by k is the radius of this one. The radius of curvature of the beam is, just assume that as 1 by k, right? And arc length is what? Dou Z. So if you will put all, what happened? R is how much? R is 1 by k. So dou theta is equals to dou L is dou Z by 1 by k. R is 1 by k. So dou theta equals to k dou Z. So this we will use later. Okay. From here, theta equals to L by R formula. Now see next. So this is the complementary energy equation for this particular beam will be there, that is d theta dm, and this is because of the virtual forces, right? So let's see what is it, in which 0 to m, this part d theta into dm is the complementary energy of an element dou Z of the beam. So for dou Z, total V is required, means 0 to m we have to integrate. This element subtend an angle dou theta at its center of curvature due to the application of the bending moment, and from here we can find the dou theta. So we can substitute here the dou theta value what we got. Now the dm is required. So once we have to find the dm, we will substitute here and integrate it. We will get the answer. So let's see here. This is the second integration, 0 to L, or you can say over the entire length. That's why it's written here L instead of writing 0 to L, or you can write 0 to L also, right? So this is the delta C. So let's see what we have the C formula. This one, just differentiate this one, right? So after differentiating, what you will get? Let's see what we have. C equals to dou C, right? With respect to what we have to differentiate, earlier also we have seen, with respect to that force. So dou C by dou P is will be what? One derivation will get cancelled. Then this will be from 0 to L dou theta by dou P into dou M minus P will get cancelled, delta V, right? The deflection. Okay, so that we got here. Okay, now what happened? This will be for the equilibrium, this equals to 0, just like previous what we did in the previous 4 derivation, same, that equals to 0. Take this delta V to this side, right? So after that what we will get? Delta V equals to integration of L d theta dm by dt. Okay, just consider this as equation 1, because this equation is very important. Here only we will find the d theta value and dm by dt value, and then we will integrate for the entire span, that is 0 to m. So this equation is for what? Either non-linear or linear elastic field. So we can use this equation in both the cases. So see, the above equation is applicable to either a non-linear or linearly elastic beam. So in both the cases, we can use this formula. To proceed further, therefore, we require the load displacement, that is m theta, and bending moment load and P relationship. So means relation between m and theta and relation between m and P we have to find. And after that, we can, or overall just the meaning of this in, we have to find dm by dp. Okay. So how we will find? Okay. So it is immaterial for the purpose to this illustrate problem whether the system is linear or non-linear. Already we are seeing this can be applicable for linear or non-linear. So here no need to identify that the given system is linear, that will behave linear or non-linear. Because that what we are using the formula that is applicable for all. Right? Since the mechanics of solution are the same in either cases, in both the cases the mechanics of solution will be same. We choose therefore a linear and theta relationship. Now we are taking just linear for the thing. Okay, as this is the case in the majority of the problem we can solve. Most of the problem we are taking the linear only, so here we are deriving for linear. So this already how we got, I explained dou theta equals to k dou z. Now from here 1 by k is what? Ei by m. So from here the fix k will be or here. This is from the simple beam theory what we have, 1 by k equals to Ei by m. So k will be equals to what? K will be equals to m by, just take the reciprocal, m by Ei. Right. Now put this k here. After putting what we will get? Delta theta or d theta is equals to what? M by Ei for k and into dou z. So if you are taking dou here, then dou z. If you are taking d, then d theta equals to m by Ei into d z. That now we can replace this d theta here. Okay. Next, in earlier also that we have to change the m. So what is m? Moment. Moment is force into displacement. So that this perpendicular distance. The perpendicular distance, how much we considered in this equation here in the figure at point z. This element, for element we are finding at a distance z. So m, that is p into z will be the bending moment, right? So m is pz. Now differentiate this with respect to p. What we will get? dm by dp is equals to z. This will get cancelled. dm by dt equals to z. Now substitute these two in equation 1. So what is our equation here? This d theta, or just I'm writing here, d theta into dm by dt. So what we have to find? 0 to L d theta dm by dt. What we got? D theta. Well, let's see here. D theta. What we got? M by Ei into dz. So m by Ei into dz into what we got? dm by dt. dm by dt is z. Okay. Now just see. We are changing this m in terms of p. So what we can write, because m moment that depends on the z. So we cannot directly take m as constant. M is not constant. So for that only we are writing here 0 to L over L and as E z by Ei into z into z. I just got this first and then we will have it. So now this P by Ei is constant. So we can take out of the integration. So P by Ei is into integration of 0 to L. This is z into z. Z squared. Right. This we have to integrate. This is our delta value. So after this what we will do? Just integrate the delta is equals to what? P by Ei. Okay. Integration of z square dz is what? Z u by 3 and here limit 0 to I. Let's see what is the integration formula? X to the power n dx. If you are integrating this one, remember we are adding the power. So x power n plus 1 by n plus 1. This is the integration. So similarly, power is here 2. So x power 2 plus 1 by 2 plus this x cube by 3. So z is there, x cube by 3. Now what we will do, we will put the limit here. So delta equals to p by pi into, so z will replace l. So l cube by 3 minus, once we put 0, so 0 cube by 3. 0 cube by 3 is what? It's 0. Right? So now next, in what? Delta equals to E by EI into L cube by 3. Okay? Or simply we can write delta equals to EL cube by 3 E. Okay? Clear? So, once see once again. What is the question? That if the cantilever beam load is acting at the meaning of this one. So because of this, we have to find the deflection, this total how much the end will get deflected. So that what is required? First we found what this d theta value. Okay, by using the concept of theta equals to L by R. We got d theta equals to k into delta. Where 1 by k is the radius of curvature of this beam. Whatever the curvature they will form after bending, their radius will be assumed as 1 by k. Okay. Now what we did, but assume at distance z, you can take x also. In this, if you are taking x, then you have to take this as dou x. That is the equation of necessary that you have to take that z only. Then this we have taken what we have the difference as from the P maxim that is the standard book. So they use this z. That's why I am also giving z because of what delta, that is not the standard book. It's not necessary that you have to use. You can take this distance as x and this as dou x also. Okay. So now with this we will count this means we will find moment at this moment for this small element and then we will integrate for the over entire answer. So first, this is the complementary energy equation, right? What we have here d theta and d. So what next step we are doing? Differentiating c with respect to p. So differentiate this c with respect to p. Then what happens? This becomes d theta and dm by dt, which will get cancelled, delta d. Right? That must be equal to 0 for equilibrium equates to 0. Hence delta d will be equals to integral of L d theta into dm by dt. So here we will get this one. So this will be the final equation in which we have to substitute the value of d theta dm by dt. D theta already we found, that we can substitute. For finding this, what is required? M theta and M2, either it's for linear or non-linear. So this equation is valid for linear as well as non-linear. But in this question, we assume that as linear because most of the problem linear. So here also we assume that the linear will be there. Linear will be there. Right? So from here, this is d theta. We know the value because we have to replace the value of k. So from the simple bending theory, we know that 1 by k is equals to pi by m. So hence k equals to m by pi. Just substitute here. After substituting in this, what we will get? D theta equals to m by pi. Now we have d theta in terms of moment. Right? E out. Next step, what is moment? Moment is equals to P into Z. Differentiate with respect to P because the C of we required what? Dou M by dou P. Whatever the moment is there, differentiate that moment with respect to P. So we will get dou M by dou P is equals to, after differentiating this, we will get as simply Z. Now dou M by dou P is equals to Z itself given. Next, just substitute all the values. So what we did, substituted this d theta value, right, and this dou dm by dt value in equation A here. So after that, what is that? Again in terms of m we are taking. So m is depending on the value of z. M depends on z. What is m? M equals to p. So replace m to p z. So after putting this, what we will get? EZ square by EI into dz. Take P, now P is constant because that applied load is constant. So P by EI will be out of integration. Only you have to integrate z square dz. Z square dz is dq by P. Substitute the limit and finally you will get this answer. Here, so this is what because of the point load, that is deflection due to point load and the complementary energy profile. So already in the aerospace structure we have seen this formula said without using complementary energy profile, and there it's easier to find in this somewhat it's a then here first you have to find this one is differential with respect to P and then find then for equilibrium equal to 0, then you will get the delta value that again you have to change d theta, find dm, whatever the moment is there. So this one is just slightly easier compared to the normal question that we studied in the mechanics of solid and aerospace structure. Okay, so now this you see this one. In the next video, you will see understanding what we will see in the next video. Okay. So this is for now we have seen for the point load. Point load. Now you will see for the uniformly distributed load. In this video, you will see. So you can refer to the maximum book for the chapter structure for many students for this problem. So if you have any doubt, you can just comment video link itself or you can ask indirectly.
Like, share and subscribe. Hit the bell icon for more updates.